So let's move on to the question number 18 here. The line 3x plus 4y equal to 12 cuts the x-axis at A and y-axis at B. The equation of the x-circle of the triangle formed by this line and the coordinate axis opposite to the vertex B is, options are, first option, x square plus y square minus 2x minus 2y plus 1 equal to 0. Second option, x square plus y square plus 4x minus 4y plus 4 equals to 0. Third option, x square plus y square minus 6x plus 6y plus 9 equals to 0. The fourth option, x square plus y square minus 12x minus 12y plus 36 equals to 0. A line 3x plus 4y equal to 12. So how does it go? It cuts the x-axis at 4, 0 and y-axis at 0, 3. Putting y equal to 0. 3x plus 4y equal to 12. Putting y equal to 0 here. You get x equal to 4. So this is the point A and this is the point B. We are given that it cuts the y-axis at B. X-axis at A. Now we are interested in finding out the x-circle opposite to the vertex A and formed by, that is, external circle like this. We are interested in finding out such a circle. Okay, we know that the center of the circle will have to be in the form of r comma minus r, where r will be the x radius of the circle opposite to B. Now we have a formula, x radius if you call this as, this will be R2, this is O, let's say, delta by x radius opposite to this vertex B will be delta by S minus OA. In radius is delta by S, x radii are delta by S minus A, delta by S minus B, delta by S minus C in a triangle ABC. So using that, R2 will be, this is R2, let's call it, R2 will be delta by S minus OA. So that is, because we are interested in the x radius of the circle of opposite to the vertex B, so we'll have to take out this OA from there. So what is S here? The semi-perimeter, where S is equal to semi-perimeter. Now how do we get the semi-perimeter? We know that this length is 3 units and this length is 4 units. Obviously this has to be 5 units. So what is the semi-perimeter? So average of, 3 plus 4 plus 5 by 2, half the perimeter. So that makes it 6 then. Okay, 6. Now 6 minus OA, what is OA here? 4. So what is your R2? R2 is going to be delta. What is delta here? Delta is the area of the triangle. Delta here is half into 3 into 4. That makes it 6 there. Okay, so R2 is delta by S minus A. S minus A, delta is 6 there. So 6 by S minus A, 6 minus, what is that? OA, that's 4. So that is 3 units. So this, now the coordinates of the center will be 3 comma minus 3. Observe that it is in the 4th quadrant, so the x coordinate is positive and the y coordinate has to be negative. This length and this length are the x radii opposite to the vertex B. So we are using that. Now let's write the equation of the circle, x minus 3 whole square plus y plus 3 whole square is equal to 3 square. That's the equation of the circle. When you expand it, it's going to be x square plus y square minus 6x plus 6y. 9 plus 9, 18, and then you have a 9 there. So that is plus 9 is equal to 0. So that, therefore, the right option is, option 3 is the right answer. Let's move to the next question. Question number 19. If A 2 comma 1 by 2, B 3 comma 1 by 3, C 4 comma 1 by 4, D k comma 1 by k are concyclic points, then the value of k is equal to. four options are k is equal to 1 by 4, second option 1 by 14, third option 1 by 24, fourth option 1 by 5. So let's have a look at this question here. We are given that A is 2 comma 1 by 2, B is 3 comma 1 by 3, C is 4 comma 1 by 4, and D is k comma 1 by k. All these 4 points are concyclic. What do you mean by concyclic? They're all lying on a circle. So they lie on some circle. This A, B, C, D will lie on a circle. But let's observe one thing here. The x coordinate of A and y coordinate, x coordinate of A and y coordinate of A, there is a relation. That is, one is a reciprocal of the other. Same is the case here also. So all these 4 points also satisfy xy equal to 1. A, B, C, D satisfy xy equal to 1 clearly. So observe that. Now let us assume that they are all on a circle whose equation is x square plus y square plus 2gx plus 2fy plus some c equal to 0. Okay. Now, but these 4 points are of the form x comma 1 by x. Can you say that? X comma 1 by x. They are all in the form x comma 1 by x. So y is equal to 1 by x, we'll put it here. Then we'll have x square plus 1 by x square plus 2gx plus 2f into 1 by x plus c equal to 0. We observe that this is now in the form of x power 4 plus 2gx cube, that is, I am taking the LCM and multiplying, or multiply throughout by x square, you can say, and then we have cx square plus 2fx plus 1 equals to 0. What did I do? I solved this circle with y equal to 1 by x line curve. So we'll get 4 points, we will get 4 roots here. Suppose x1, x2, x3, x4 are the roots of this. Are roots of this. They are roots of this equation. Now x1 would have been this, x2 would have been this, x3 would have been this, and x4 would have been this. What is the product of the roots when you have a polynomial like equation like this? Product of the roots is x1 into x2 into x3 into x4 is equal to, observe that it is 1 by 1 here. That is the constant term divided by the coefficient of x power 4 here. So that's 1. But what is x1? 2. So 2 into 3 into 4 into what is the k value here? So that's equal to 1. So therefore k is clearly 1 upon 12 to the 24, 1 by 24. K value is therefore 1 by 24. So what is it we have used? We made an observation that all these 4 points are also lying on the curve xy equal to 1. That's a hyperbola, rectangular hyperbola. Now, but they are also given to be concyclic. So therefore there will be point sums and circle. So that circle we have taken it as x square plus y square plus 2gx plus 2fy plus some c equal to 0. And now we solve this circle with the curve y equal to 1 by x. So we got a biquadratic equation in x, for which these would have been the roots. The x coordinates of these 4 points must have been the roots. So x1, x2, x3, x4, we assume it as the roots there. Out of them, x1 is this, x2 is this, x3 is this, x4 is k. So I substitute it here. Product of the roots, we observe that it is a coefficient constant term divided by the coefficient of x power 4 here. Product of all the roots taken the time. So that's 1 by 1 there, and therefore it is k is equal to 1 upon 24. So the right option is option 3 is the right answer. Let's move to the next question, question number 20. If the lines x plus ky plus 3 equal to 0 and 2x minus 5y plus 7 equal to 0 intersect the coordinate axis in concyclic points, then the k value is what? Options are 2 by 5, minus 3 by 5, 3 by 2, fourth option minus 5 by 3. Let's have a look at it. So there are two lines, some x plus ky plus 3 equal to 0, something like this, and we have another line 2x minus 5y plus 7 equal to 0. Let me say these are the two lines. I have not plotted them exactly, but let's think that these are the two lines. Now these 4 points are concyclic points, they say. So there is a circle passing through them. Circle passing through these 4 points. Now how do you write that circle? This is y equal to 0 line. This is the line x equal to 0. Okay, you are given two lines L1, x plus ky plus 3 equal to 0, that is x1. This is the line. And the line we have 2x minus 5y plus 7 equal to 0. Now if you consider an equation L1 into L2 plus lambda times xy equal to 0, see this is, one of them is L1 equal to 0, another line is L2 equal to 0. Let us consider these points as A, B, C, D. A, B and then C, D. If you consider this is a second degree equation, because when you multiply two linear expressions you get a second degree expression, and this is a second degree expression already. Lambda some parameter, lambda some real number, some parameter, so that's not going to add to the degree here. So L1 L2 is going to be of degree 2 and xy is of degree 2. We have a second degree equation. I say that this second degree equation is satisfied by all these 4 points A, B, C, D. Now just check. L1 at A is 0. So if I substitute A here, that is going to make L1 0. What about this? A lies on the line y equal to 0. So A will have a y coordinate as 0. So when I put this A here, I am going to get 0 here also. So similarly with B, similarly with C and D, all these 4 points will lie on this curve. But then we are saying that this has to be concyclic. A second degree curve, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a circle, we know, represents a circle if and only if a is equal to b, that is the coefficient of x square is equal to coefficient of y square, and the coefficient of xy is 0. So represents a circle. This is a key point there. The key point that you have to remember is this. That is, whenever you have a second degree equation like this, that would represent a circle provided the coefficient of x square is equal to coefficient of y square and the coefficient of xy is equal to 0. Now I have a second degree equation here, L1 into L2 plus lambda into xy equal to 0. But we want that to be a circle, right? For that to happen, what should happen? First of all, coefficient of x square must be equal to coefficient of y square in this product. What is this here? Observe that it is x plus ky minus plus 3 into 2x minus 5y plus 7 plus lambda into xy equal to 0. Lambda into xy equal to 0. So what is it? The coefficient of x square, let's club. What is the coefficient of x square here? X into 2. So x into 2x will give me the x square term. No other way can we get the x square coefficient. So that's 2. What is the coefficient of y square? What is the coefficient of y square here? K into minus 5. So that's going to be minus 5k. Preliminarily, we want the coefficient of x square to be equal to coefficient of y square. Okay, so I'll want 2 is equal to minus 5k. Therefore, k has to be definitely minus 2 by 5. k is equal to minus 2 by 5. Alright. So now the next part is, we can always choose a lambda such that the coefficient of xy will be 0. What is the coefficient of xy? Here I'll get minus 5 plus 10k plus lambda. That you can always make it 0 by choosing a suitable lambda there. So what we want actually is that coefficient of x squared to be equal to coefficient of y squared. Anyway, we can choose a lambda, suitable lambda, so that coefficient of xy is 0. So k has to be minus 2 by 5. So the answer is 1. Let's move to the next question, question number 21. The circle x square plus y square minus 6x minus 10y plus k equal to 0 neither touches nor intersects the coordinate axis, and the point 1, 4 lies inside the circle, then k lies between 9 and 29. Second option, k lies between 9 and 25. Third option, k lies between 25 and 29. Fourth option, k lies between 0 and 29. Now the circle has to be neither cutting or touching any of the coordinate axis. So it has to be completely lying in one of the quadrants. So now, in which quadrant should it lie? Tell me. Here the quadrant should be in the first quadrant because it has to contain the point 1, 4. So 1, 4 is in the first quadrant. So the circle must be in somewhere like this. Okay. So now center what is the center of this circle? We know that the center of this circle is 3, 5 because the circle is given to be x square plus y square minus 6x minus 10y plus k equal to 0. Clearly, now we observe that this is 5 units. That 5 has to be greater than the radius. So what's the radius? 5 must be greater than radius. And what is the formula for the radius? When you have the circle as x square plus y square plus 2gx plus 2fy plus c equal to 0. So the radius is under root over g square plus f square minus c. So what we have here, what is the radius? 3 square plus 5 square minus k. So that makes it under root of it 9 plus 25, 34. 34 minus k under root. Your phi should be definitely greater than the radius. So phi should be greater than under root of 34 minus k. So 25 should be greater than 34 minus k. In other words, k should be greater than 9. This says that k should be greater than 9. So we want the radius to be less than 3 also. So what is the radius? We have got 34 minus k under root. So root 34 minus k should be less than 3. In other words, your 34 minus k should be less than 9. So k should be greater than 34 minus 9, that is 25. K should be greater than 25. But we said here that k should be greater than 9. Combining these two facts, we can say that when is the combination of both the things so going to happen? So k should be greater than 25. So k should be greater than 25. Clearly, only one of the options is satisfying that. But anyway, one more thing also we need to take into consideration. This point 1, 4 lies inside it. That means the distance from 3, 5 to 1, 4 must be less than the radius. So we can use that also. What is the distance between 3, 5 and 1, 4? 3 minus 1 whole square plus 5 minus 4 whole square must be less than the square of the radius. What is the square of the radius? 34 minus k. Okay, so that should happen. So we have here 4 plus 1 should be less than 34 minus k. So that is 34, k should be less than 34 minus 5 there, that is 29. So k has to be greater than 25 and also less than 29. So combining these two facts, we can say that k should lie between 25 and 29. Okay, so what did we use? We have observed that the circle has to be entirely in the first quadrant because it has to contain 1, 4 and it should not intersect any of the coordinate axis or touch any of the coordinate axis. So therefore, what should happen? This radius has to be less than 5 units, that is the y coordinate of this center here, and also it has to be less than 3. In fact, we could have said straight away, instead of writing this, radius has to be less than the minimum of these two, so it has to be less than 3 there. So under root of 34 minus k is less than 3, so I would have got straight away k greater than 25. And we are to use the fact that this point 1, 4 lies inside the circle, therefore the distance from center to that point has to be less than the radius. So using that, square of the distance from 3, 5 to 1, 4 is less than the square of the radius 34 minus k, therefore we got k to be less than 29. So combining these two facts, k has to be lying between 25 and 29 there. So the right option is option 3 is the right option. Let's move to the next question. Question number 22. The square of the intercept made by the circle x square plus y square plus 2hx cos alpha plus 2ky sin alpha minus h square sin square alpha equal to 0 on the x-axis is. First option 2h square, second option 2h, third option h, and fourth option 4h square. Let's have a look at this. Now what do you mean by the intercept made by a circle on the x-axis? X square plus y square plus 2gx plus 2fy plus c equal to 0. Suppose this is the circle equation and this is the x-axis. Let us say it is cutting the x-axis at a and b, 2 points. Then AB is the x-intercept. There is a formula for it. To find out this AB length, it is 2 root g square minus c. And if it is cutting the y-axis as well, suppose the circle is cutting the y-axis, the same circle, this is the y-axis, the length of the intercept of the y about the y-axis, suppose this is point C and D, then the CD length is given by 2 root f square minus c. Now what would be the condition that the circle touches the x-axis? That means this A and B should coincide, meaning AB length should be 0, g square should be equal to c. Similarly, if the circle has to be touching the y-axis, f square should be equal to c. I mean, this is not exactly connected with this question, but some additional information. Here, coming back to the question, we are given the circle to be x square plus y square plus 2hx cos alpha and 2ky sin alpha minus h square sin square alpha equals to 0. This is the equation of the circle given. Comparing with this, what is in place of g? In place of g, it is half the coefficient of x. So what's the coefficient of x here? 2h cos alpha. Half of it will be your g. So what is the length AB? What we want is the square of the x-intercept. Right. So AB square is what we want. That makes it 4 into g square minus c. What is in place of g? That is h cos alpha. So 4 into h square cos square alpha minus, what do we have in place of c? A minus of h square sin square alpha. So minus of minus, that makes it, what do we have here? So finally it comes out to be 4 into minus of minus will make it plus there. H square can be taken common. Cos square alpha plus sin square alpha is 1. So we have 4h square is the square of the x-intercept there. So the right option is, option is 4. Let's move to the question number 23. If the lines represented by 4x square plus 12xy plus 9y square minus 6x minus 9y equals to 1 are two tangents to a circle, then its area is. First option 5 pi by 13, second option pi, third option pi by 2, fourth option pi by 4. Here observe that the equations combined, it's a combined equation of two lines, 4x square plus 12xy plus 9y square minus 6x minus 9y plus minus 1 equal to 0. We know that whenever you have an equation like this, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, and if it represents a pair of straight lines, suppose it's a pair of straight lines, combined equation of a pair of straight lines, they would be parallel if and only if h square is equal to ab. Parallel if and only if h square is equal to ab. Here, do we have h square to be ab here? What is h? 6. In our question, h is 6. So h square is 36. What is a? 4. What is b? 9. So h square, is it equal to ab? Yes. So we are finding that h square is equal to ab. So indeed, these two lines, combined equation of these two lines would represent a pair of parallel lines, but they are also given to be tangents. So we have pair of parallel tangents. So they must have been pair of parallel tangents. That means the distance between them will be the diameter of the circle. So how do we find out the distance between them? Okay, now we can write this equation in the form of 2x plus 3y the whole square plus minus 6x minus 9y minus 1 equal to 0. We can split this equation in the form of two lines like this, 2x plus 3y plus some k1 into 2x plus 3y plus some k2 equal to 0. Two parallel lines. Two parallel lines differ only by a constant we have. So we have k1, k2 here. Now what we want is the distance between them. What is the distance between them? Modulus of k1 minus k2 by under root over 2 square plus 3 square will be the distance between the two parallel lines, which will be actually the diameter of the circle. But how do I get this k1 and k2? Observe that k1 into k2, we will identify this equation with this. K1 into k2 has to be the constant term here. So what is k1 into k2? That's minus 1. So k1 into k2 is minus 1. And also let us observe that we have the coefficient of x. What do we have the coefficient of x to be? 2 into k2 plus 2 into k1. That is the coefficient of x. So that is 2 into k1 plus k2 is equal to the coefficient of x. What is the coefficient of x here? Minus 6. So minus 6. So k1 plus k2 has to be equal to minus 3. k1 plus k2 is minus 3. Now what is k1 into k2? 1. Minus 1. k1 into k2 is minus 1. From these two, we can get the value of modulus of k1 minus k2. What is the modulus of k1 minus k2 here? Therefore, we have modulus of k1 minus k2 to be equal to k1 plus k2 the whole square minus 4 k1 k2 under root. Under root. So what is that? That is minus 3 the whole square minus 4 into minus 1. So that makes it 9 plus 4 under root. So that's root 13. So we have root 13 there. Modulus of k1 minus k2 is root 13. And what do we have d to be there for? D is equal to root over 13, that is modulus of k1 minus k2 divided by root over 2 square plus 3 square, that is nothing but 1. So d is 1. So this entire diameter is 1. This is 1. So what should be the radius? Clearly the radius is half. Radius is half. Radius is half. Therefore, area of the circle, area will be pi r square. Pi into r square, that is pi into 1 by 2 square, that is equal to pi by 4. So that's the answer. So option 4 is right. Option 4 is correct. Let's move to the next question here. 24th question. If the angle between the tangents to the circle x square plus y square equal to 4 at A and B is 60 degrees, then what is the length of AB? Options are first option 2, second option root 3, third option 1, fourth option 2 root 3. Now we have a circle x square plus y square equal to 4. Clearly it is with origin as the center and the radius is 2 units. Let us think that this is A and this is B and the point B, and we have tangents at A and B making an angle 60 degrees. They're making an angle 60 degrees here. So this is going to be at 90 and this is 90. Let's join this point P with the center. Clearly this AB will be bisected by this line as well. It will be, in fact this will be perpendicular bisector of AB. And this triangle PAO and PBO, they are congruent. The triangle PAO is congruent to the triangle PBO. PBO triangle here. Now what we want is AB length. What do you know about the length of OA? That is 2 units. Okay. Now this angle is 60, the total angle is 60 here. Therefore, what will this angle be? 30. Because this is in the right angle triangle, I'm sorry, this is 30, so this will be 60 here. So let's call this point as some M. If you consider the triangle AMO, consider the triangle AMO. Okay, what do we know? AM divided by AO. That will be sine 60, because opposite by hypotenuse. This is opposite to the angle 60, AM is opposite to the angle 60 and AO is the hypotenuse there. In this triangle AMO, that's a right angle triangle there. But what is AO? We know it is to be 2. So what is AM length? 2 sine 60. But what is sine 60? Root 3 by 2. So that makes it root 3. But what is AM? Half of AB. So AB will be equal to 2 times AM. And that is equal to 2 times of root 3. We use a simple geometry here. What did we observe? We are given that the angle made by the tangents at A and B is equal to 60 degrees. Now this PO line is going to be bisector of that angle. Therefore this angle will be 30 degrees. This also be 30 degrees. Now consider this triangle APO. This is 90 and this is 30. This part is 30. Therefore this has to be 60. Now coming back to this triangle AMO. In the triangle AMO, now we again apply sine theta is equal to opposite by hypotenuse. So AM by OA, that's equal to sine 60. Therefore AM is equal to 2 sine 60, and therefore, but what is AB? Twice of AM. So we have 2 root 3. Therefore the right option is option 4 is the right option. Let's move to the next question. Question number 25. Equation to the tangents to the circle x square plus y square minus 4x plus 4y minus 10 equal to 0, which make an area of 18 square units with the coordinate axis are x minus y equal to plus or minus 6, x plus y is equal to plus or minus 6, third option x plus 2y is equal to plus or minus 6, and fourth option x plus y is equal to plus or minus 9. Here it's better we go from the options. We will eliminate the options. We will check which of the options is correct here. Now we'll corner on the right option. What is it you observe? The center of the circle is 2 comma minus 2. What is the radius? Radius of the circle? 2 square plus minus 2 square minus of minus 10 under root. That's the radius. So that makes it 4 plus 4, 8. 8 plus 10, 18. That is 3 root 2. 3 root 2 is the radius. Now, which of the circles will have the perpendicular distance, which of the lines will have the perpendicular distance from center to that line to be equal to the radius? Now that is the criterion for the tangency. And now what else? Let's see from there. He says that the area made by the line with the coordinate axis. What is that? If the line is at the form x by a plus y by b equal to 1, then this area is given by half mod AB. That is half of the product of the x-intercept and y-intercept there. Now that has to be your 18. So what is it? The product of the intercepts must be 36. So that's what we want. Now in the first two options, x minus y equal to plus 6 plus or minus 6, we observe that modulus of AB here is 36. So this could be one of the possible answers. Second possibility, so this may be possible. Secondly, x plus y equal to 6 plus or minus 6 is also a possibility. Again here the product of the modulus of the product of the intercepts is 36 even here. Okay, so we have here in both the cases this is a possibility. So we put a question mark here. Out of these two, which could be the tangent to the circle? So that has to be verified there. For that, what is it? Condition for tangency for the circle is, for a line to be a tangent to the circle is what? Perpendicular distance from center to the line must be equal to the radius. So let's equate that. Let us see if that's happening with the first line or the second line. So observe that. What is the perpendicular distance from center 2 comma minus 2 to this line? So 2 plus 2 minus of minus 2, this plus or minus 6 we are saying, divided by under root over 2 there. That's the perpendicular distance. That is from 2 comma minus 2 to this one of these lines. I'm writing them. I'm finding that is equal to 4 plus or minus 6 by root 2. If it is 4 plus 6, 10 by root 2, that makes it 5 root 2. That can't be done. That is not matching with the radius. So 4 minus 6 under modulus, that makes it 2 by root 2. That also doesn't match with the radius. So this is not equal to 3 root 2 in either case, whether it is plus or minus. But when it comes to this, it would be, what is the perpendicular distance here? Distance from center to this line, either of these lines, x plus y equal to 6 or x plus y equal to minus 6. Let's find out that. What is it you get? 2 plus minus 2 plus or minus 6 by root 2. That makes it 6 by root 2. That is 3 root 2. Which is matching with the radius. It is matching with the radius. That is, the perpendicular distance from center to this line is coming out to be equal to the radius. So what does it confirm? It confirms that this line can be the tangent to the circle. And is it obeying this thing? that area enclosed by that line with the coordinate axis is 36. That is all 18 square units. That is also obeyed there. So product of the intercepts is 36. That's what we wanted, and we wanted that's happening in both the examples, both these lines. But we observed that this cannot be the tangent, so this is ruled out. Therefore, the right option is the second option. Option 2 is the right answer. Okay, let's move to the next question, question number 26. If the tangents at the points 1, -3 and -3, 1 of a circle are perpendicular, then the radius of the circle is first option 2, second option 4, third option 8, fourth option 16. Now it just comes from a simple geometry here. Let's plot the two perpendicular tangents. So let's say we have a tangent here 1, -3, and we have another tangent which is perpendicular to it at -3, 1. This is 90. Okay, if you join from center, if you draw a line perpendicular to this, that's going to be the radius. It's also the radius. This is 90, is also 90. So all the four. This is going to be a square now. Square with the diagonal end, one diagonal given by the end vertices as 1, -3 and -3, 1. So if this is R, what will be this? Let's call this as A and this is B, right? AB length is clearly R √2. Okay, but what you wanted is R. So R will be equal to AB by √2. AB by √2. So what do we have here? What is AB length? 1 minus of -3 the whole square under root plus -3 minus 1 the whole square under root. That is AB length. So that makes it 4 square plus 4 square. So that is 4 √2 there. AB is 4 √2. So AB is 4 √2. What is AB by √2 then? AB by √2 is 4. That's our radius R. Therefore, the radius of this circle that we are looking for is 4 units, and clearly the option 2 is right. Option 2 is correct. Let's move to the next question, question number 27. The line y equal to x is a tangent at origin to the circle of radius unity. Then the center of the circle is first option 1, 0, second option 1 by √2, 1 by √2, third option -1 by √2, 1 by √2, and fourth option -1 by √2, -1 by √2. The line y equal to x is a tangent to the circle at origin. Let's plot it. This is the line y equal to x. Now I want the circle to be having this line as a tangent. So where should the center of that circle be? It should be perpendicular to this. It should lie on a line perpendicular to it. So what is this line? Y equal to -x. Clearly that actually rules out all the four. Out of the 4 options, first, second and fourth options are ruled out, because a circle which is touching this line y equal to x at origin should have its center definitely on the line perpendicular to this y equal to x passing through origin. So what should it be? It should have its center on the line y equal to -x. So clearly only one option can be satisfying that. So answer is 3. Let's move to the next question, 28 question here. If the chord y equal to mx plus 1 of the circle x square plus y square equal to 1 subtends an angle of measure 45 degrees at the major segment of the circle, then the value of m is first option ±2, second option -2 ± √2, third option +1 - 1, Fourth option, none of these. Let's plot this. Let us visualize the situation. X square plus y square equal to 1 is a circle with the center as origin and the radius as 1. So this will be 0, 1 point. This is 1, 0, a minus 1, 0, and 0, minus 1 here. Now y equal to mx plus 1, this line y equal to mx plus 1 always passes through whatever may be m, it would always pass through the point 0, 1. This is our line y equal to mx plus 1. The dotted line is our y equal to mx plus 1. In for different values of m, I get that line. But then he says that chord should be subtending an angle 45 degrees here. If this is 45 degrees, what is the angle subtended by chord? At the center it has to be 90. So how should the chord be? Obviously the chord should be joining 0, 1 and minus 1, 0, because that's the chord which is passing through 0, 1, which would be subtending an angle 90 at the center of the circle. So when a chord subtends an angle theta at major segment of the circle, then it subtends an angle 2 theta at the center of the circle. So what is it we have? Okay, so this should be 90. Obviously this y equal to mx plus 1 should also be passing through the line a point minus 1, 0, or it could be passing through 1, 0. So in either case, what is the slope of this line? 1 minus 0 by 0 minus of minus 1, that will be 1 there. So either the slope m has to be equal to plus 1 or minus 1. Clearly, what is the chord that is passing through 0, 1 and which is subtending an angle 90 degrees at origin, that is the center? So it is this chord only, 0, 1, chord joining 0, 1 and minus 1, 0, or chord joining 0, 1 and 1, 0. So in either case, in this case the slope is 1, in this case the slope is minus 1. So the value of m has to be either plus 1 or minus 1. So the right option is 3. Option 3 is right answer. Okay, let's move to the next question. Question number 29. The centers of the set of circles, each of radius 3, lie on the circle x square plus y square equal to 25. The locus of any point on this set of in the set is, first option, x square plus y square greater than equal to 4 less than equal to 64, x square plus y square less than equal to 25. Third option, x square plus y square greater than equal to 25. Fourth option, x square plus y square greater than equal to 3 and less than equal to 9. We have a circle of radius 5 units with the center as origin, that's given. Now there is a circle of radius 3 with center lying on this. Okay. Now the set of points on this circle, these are the circle. Observe that this point, if you see this, join up this center and this center, this length is 3 units, this is already 5 units. So we are interested in the set of points on this this circle. We observe that if you take this point as x, y, if this is x, y, distance from x, y to origin is at the farthest, and x square plus y square under root is less than or equal to 8 for all other positions, because that is the farthest point. And the closest point will be here, this length. How much is that? 5 minus 3. This entire thing is 5. You subtract out 3 from there, so that will be 5 minus 3. So your root over x square plus y square has to be greater than or equal to 2. So for all possible points here, you take any point here on the circle and taking that as a center, you draw a circle of radius 3. The farthest point from the center will be at a distance of 8 units, and the the closest point will be at a distance of 2 units. So root over x square plus y square will lie between 2 and 8. Therefore, x square plus y square has to be lying between 4 and 64. That is, he said the set of points on the circles with the centers lying on this circle of radius 3. So these points, all these points, they will be obeying this kind of chain of inequalities. Root over x square plus y square. So you take any point on these circles as x comma y, take any points here. The farthest point is at a distance not less than or equal to 8, So root over x square plus y square is less than or equal to 8 and greater than or equal to 2. Why the 2? This is 5 minus 3, 2 there. This is 2 units. This is 5 plus 3, 8 units. So x square plus y square should be therefore lying between 4 and 64. So the right option is, answer 1 is the right option. So let's move to the next question, question number 30. The centers of the circle passing through 0, 0 and 1, 0 touching the line x square plus y square equal to 9 can be half, half. Second option, half, minus root 2. Third option, 3 by 2, half. And fourth option, 1 by 2, 3 by 2. Let's again visualize this. X square plus y square equal to 9. It's a circle with the center as origin and radius as 3. That's it. Now 0, 0. A circle which is passing through 0, 0 and 1, 0. This is 1, 0, let us say. This is origin 0, 0. We have a circle which is passing through these 2 points and also touching this circle. It can't be obviously touching the circle externally. It has to be therefore touching it internally. Okay. Now, clearly the center of any circle has to be on the perpendicular bisector of any chord. Now what is the perpendicular bisector of this chord joining 0, 0 and 1, 0? That has to be the line x equal to half. So this circle, that is the dotted line circle, which is passing through 0, 0 and 1, 0 and touching this circle of radius 3 internally, that must be having its center on the line x equal to half. So it must be having x coordinate of the center as half unit. So it is half, some k, we'll call it as. Center will be half, k. Now observe that this distance, if you join up the point of contact of these 2 circles and this, that has to be a diameter of it. Or in fact that is the diameter of the inner circle and it has to be the radius of the outer circle. So what is the radius of the outer circle there? The radius of the outer circle is 3 units. So 3 is this distance. So that by 2 will be the radius of the inner circle. You see that it's touching here. You join up origin with this point of contact, that will become the diameter. Okay. Now that's the diameter for the inner circle. And that's the radius for the outer circle. What is the radius for the outer circle? That's 3 units. Therefore, radius of the inner circle must be equal to 3 by 2. Now, so this length is 3 by 2 here. Okay, so this is 3 by 2. Now observe that. So from half, k to origin, the distance is 3 by 2 units. 3 by 2 units. So let's use that. Half square plus k square must be equal to 3 by 2 square, that is 9 by 4. Let's look at that. So that makes it k square is equal to 9 by 4 minus 1 by 4. That is equal to 8 by 4. That's equal to 2. So what is k value? K has to be plus or minus root 2. K has to be plus or minus root 2. So the possible coordinates of the center are half comma root 2 or half comma minus root 2, because you could have one more circle like this which will be touching it here. So there are two possibilities there. One of the circles is with the center is half comma root 2. The other circle will have the center as half comma minus root 2. So this is half comma minus root 2. We have, he is given only one of the options there, but there are two possible circles. So the right option would be answer 2. Answer 2 is the right option of the given options. Okay. Actually speaking, you can say it is half plus or minus root 2. So those are two possible circles which are passing through 0 comma 0 and 1 comma 0 and touching this given circle, x square plus y square equal to 9 internally. So if you, most of these questions here will become very easy if you are able to visualize the situation. So the answer is 2 there.